Welcome to VPixx's video interview series, Meet the Expert. My name is Lindsay, and today I have with me fellow VPixx Staff Scientist Dr. Sophie Kenny, who will be talking to me about how we install our PROPixx projection systems in very small spaces. Sophie has over 5 years of experience at VPixx consulting on how to install our PROPixx projection system in a variety of magnetically shielded and behavioral environments, ranging from large MRI facilities to teeny tiny OPM booths. Thanks so much for joining us, Sophie.
No problem. It's really my pleasure.
So before we get started, can you tell me a little bit about your role at VPixx? So what does a staff scientist like yourself do at the company?
Yeah, sure. So as staff scientists for VPixx, a big part of our roles involve assisting researchers and technicians setting up their research spaces and also understand how it works much better. So we do one-on-one consultations via emails, phone calls, video calls, but we also do VSS satellite sessions and lots of educational material that we try to put online, try to get the word out about technology.
So as part of those consultations, we've had a lot of researchers contact us asking about projection systems specifically for new MEG and OPM research. What are some of the advantages of using a PROPixx for this kind of research?
So what's really interesting about the PROPixx is that it's really our most advanced visual simulation solution. So not only it's a low latency system, but really it has specific advanced video modes for research. And one of those that we're seeing a lot of traction with is the 1440 hertz, so that's 1440 hertz mode. It allows really fine temporal and resolution on the definition of your stimuli. And in MEG, OPM, some EEG spaces, what we've seen is people are really interested in using it for rapid frequency tagging. And what that consists of is embedding multiple frequency tag that are too smooth for the visual system to perceive it, but they're in a frequency band that can be picked up as a neural signature in lower level and higher level cortices. So whenever you're using that mode to study reading, attention, design brain-computer interface, it provides a neural signature that can be picked up and that is spatially dependent. So it's a really interesting feature.
And it's completely invisible, right? It's not something that your participant's going to detect, say, if they're a young person or maybe unused to research. It's sort of a secret technique almost.
Exactly. And the nice thing is it allows you to study attention, for example, without any overt eye movement, which is often a very difficult confound for these neural techniques.
So let's say that I'm a researcher and I already have a magnetically shielded room on my campus, and I want to install a projection system for a new OPM setup. What are some of the things that I need to keep in mind as a researcher when I'm planning this kind of installation?
Yep, it's a good question. So I'm going to start with a piece of good news. The nice thing is the body of the projector itself, the algorithms, all of those video modes, they're the same regardless of where you're going to be using the PROPixx. So if you're somebody that's been using it at a behavioral lab or an MRI or an MEG and all that, you're not immediately going to have to consider, well, the underlying technology is going to have to change because X model this. No, what we do is essentially that body stays the same, but we look at the projection geometry, the screen requirements, the subjects, how they're going to be set in those spaces, etc. So if I can take a little bit of time to explain, to show some information or give a little bit more context, just give me a second. I've prepared a little something. There you go. So I'm going to start by giving a little bit of general tips or a general checklist on how you can figure out if a projector system is going to fit in a space, any space. So regardless of whether you're doing behavioral or MEG, OPM, etc. Okay, then we can talk about more specific details. But whenever people come to us and ask about installing a projector system, you'd be surprised with how many people haven't even started to consider the physical space in which they want to install that system. So what I advise people is to first take a good look at the structural considerations with your rooms. So what's the room size? What's the width? What's the depth? What's the height? Where are the doors? All right. Are there obstructions, occlusions that prevent you from installing some equipment in those sections? Are there windows? Are there any viewing panels? Are there any other permanent fixtures that might restrict your use of that physical space?
The permanent fixtures is a really good one. I'm thinking of a particular MRI installation where we had a cabinet that wasn't in the floor plan but couldn't be moved. And that became a real challenge during installation. So yeah, anything that's anticipated to be in the room for sure.
Yep. So that's what's a really good thing is if you're setting up a new space or you're taking up a new position at a research institution is really to, as you're viewing the facilities, just start doing a sketch, writing down those observations, those measurements, because later on down the line, when you have to start using that space, they'll become important.
Definitely.
So some other things that people don't always think about is how are you supposed to function within this room? So how do you expect your participant to move within this room, if at all? Is a research assistant supposed to come in and do certain procedures and have to navigate around equipment? I'm thinking about primates or OPM or MEG facilities where somebody might have to come in and while something is being presented, adjust various details or take certain measurements with the other equipment that's in there. So it's good to think about what are the where people are going to be walking or what parts they're going to be able to what parts they might need to use. So once you have a good sense on how you're going to be using that space, it's good to start looking into whether your specific facility has additional considerations that might limit or make this installation a little bit more complicated. So, or OPM rooms.
This is more of a booth than a room, honestly. A room's a stretch.
Yes. And there's increasingly common. I would say, 5 years ago, we didn't see those that often. But sometimes those rooms, they can be really, really constrained. So where that door is, where the openings are, where your participant is sitting, you're posing a lot of different constraints.
Mm-hmm. That's the projector on the ceiling there, isn't it? Can you show it for a minute?
Oh, yes, I can. Yes, I can. So that's an example of a very difficult room to work with, where one of the only likely locations was to install the projector through a waveguide, a little hole in the ceiling, and to redirect the projection path with mirrors onto the screen.
Wow.
Yeah. So sometimes they're very interesting.
So that's actually a really good point. So can you talk a little bit more about waveguides in particular with these magnetically shielded rooms? What are they for and where do they usually end up?
Yeah. So when you're in a behavioral room, like I was showing just before, you're typically not limited about where you can put your projector. But when you're doing neural recordings, and especially neural recordings that are sensitive to electromagnetic noise or certain radio frequencies, some of those equipment come with constraints that you have to shield them from potential noisy interference. So those facilities like the MEGs, the OPMs, MRIs, they're housed, or not those facilities, but those equipment, they're housed within magnetically shielded rooms. So very thick, metallic, specialized rooms that keep out as much as possible all of the electronic equipment from out of there. The problem is if you've ever tried to project through a wall, you know that not much can pass through this. So you need an opening. And those openings, they're typically called waveguides. So this is just a schematic representation of one type of waveguide that we often see. Imagine you have a projector, And to go through the wall, you have to have an opening of a certain dimension. And then you have to project it onto a projection surface, perhaps a projection 3D screens. Maybe you'll have to have redirected the light with a mirror. But so one of the things that happens with this is whenever you have to project an image towards a screen, that implies that there's a projection cone that gradually gets bigger and bigger and bigger as you're getting farther away from the projection origin. But you have to go through a hole. So one of the key constraints of these is figuring out what's the maximal image size that can pass through a waveguide. So there's some simple trigonometry that you can do to figure out what's the maximal image size that can pass through this, and consequently the maximum image size that you can get onto a projection screen. But yeah, so that's their role, to let information in. Oh, well, actually, so sure, they're holes, but if you could do just any hole, why not just keep the door open, right? So the idea is that the magnetic shielded room engineers that design those rooms, they have certain sets of constraints and guidelines with how wide those openings can be and what type of shapes those waveguides can be. So that one of the most typical shape that we see is those cylindrical waveguides. So they tend to be about 4 times as long as they are wide. But there's also rectangular ones. Sometimes we've seen more conical ones. So, and our job or our role as staff scientists in all of this to advise whether that's the design that's been proposed is something that can be compatible with desired image size, or likewise, if we can do a little bit of back and forth to see whether it can be tweaked a little bit for our needs.
I was going to say, so it's generally like the larger the waveguide, the better, right?
No, definitely, and definitely for projection purposes. And it's funny because in conversations, what you find is that there's a sort of nomenclature or convention that's evolving to describe when a certain diameter is expected to be used for something or another. So you hear things like, oh, so we do have penetration panels, or we have data waveguides, or we have projection waveguides.
Right.
Yeah.
Which may or may not be used for those purposes.
Yep.
So let's say that I'm planning a brand new research facility. My magnetically shielded room isn't even built yet. Can you give me any recommendations for things to consider during the room design phase? You know, what's our best case layout?
That's a good question. So I guess I've mentioned a few times already that often we can weigh in or give some suggestions, right? So it's good for you to have, or for our listeners today to have a good sense of what could be possibly modified or adapted, or what topics they could raise with the designers, or even with us during a consultation process. So, okay, let me share my screen again.
Another very tiny room.
Yeah, so that's the same one as earlier, but just with a little bit of a 3D rendering there. The magic of cinema. So these are all very broad rules of thumb, because any change in layout or positions of waveguide or physical constraints with the actual facility or the building where these rooms are going to be installed, they could all impact final decisions, or the relevance or importance of those guidelines. But so rule of thumb: if you're finding yourself in a tiny room like this one, what I've observed is that, expect that you'll have image sizes that'll be equivalent to no bigger than typical computers monitor sizes, like 24-inch diagonal, 27-inch diagonal, 16:9 aspect ratio. The projection distance is so short in these ones that you rapidly exceed the potential diameter that can be practiced on those waveguides. So sometimes, sometimes like full peripheral vision projection might not be so practical or so plausible in those scenarios. If you have the chance to go for a larger room, then that gives you much more flexibility for where your participant might be sitting, if they can be standing, where the screen could be placed relative to the participant, and the whole range of image sizes that can be produced. So you can imagine that if this room was about twice as long and we were able to do a waveguide on the back wall instead, we'd be able to have a much longer distance, much smaller projection cone, and the image size would have much more chance to grow while it is within the room before hitting that projection screen. So much more flexibility, much more potential placements, all of this. It's always best to look at trying to plan your waveguide opening behind the projection screen. So we call that rear projection. If you're ever doing a consultation with us, I'd be really happy to talk about all of the details, why that leads to a much smoother installation than people might think otherwise. But it basically allows you to do a projection directly onto the projection screen without having to be concerned about, am I going to have neural sensors in the way? Is a research assistant walking through the room going to occlude the projection beam during testing? Bypassing digital processing artifacts that might otherwise be needed if you were trying to do really steep front projections, things like that. If you're at the room design process, when you speak with the magnetic shielded room engineer, try to see how you can maximize the diameter of the projection waveguide inside the MSR room. So I've alluded to the fact that there can be multiple designs. One of the ones that I like seeing the best is the conical design. The reason is because it allows the engineer to keep the opening outside the room very, very small. So, often 10 centimeters. But inside the room, you can get 2 times or even a little bit more often bigger than that.
Right, so you're preserving the integrity of the room, but you're still taking advantage of that sort of triangular shape of the beam of light.
Exactly, exactly. So another discussion too with the engineer is whether the waveguide length can be minimized. So sometimes the waveguides are going to be able to be flush with the depth or the thickness of the wall or the ceiling in this case, but sometimes those waveguides are actually going to be much longer, and they might protrude from either end. So sometimes you'll find that there's an extra 10 centimeters outside, inside. Sometimes just displacing it a little bit is going to help find an optimal projection geometry in there. So that's an interesting thing, and that's the type of concerns that we can help you with or counsel with.
Right. So generally speaking, if you have the sense of the dimensions of the room, where the screen's going to be, and what the waveguide looks like, you can kind of get an idea of what that final image, that maximum image size will be, right?
Yep. No, that's exactly it. And I think my last piece of advice too is that for that waveguide location. So I've had a lot of fun showing this image right here, but that's really not the optimal scenario. It involves having to install a projector, sometimes checking whether it intersects with ceiling structures, vents, etc. What we'd most often see, especially in the larger rooms, is a waveguide that's directly in line with the middle of the projection screen. It's really easy. Don't have to consider mirrors, especially if the mirror is large. If that's not possible, to put it very high up or very low down on the same wall. And there you end up having to do some mirror systems, just like in this case right here. But that's also something that's quite common that we see very commonly in MEG facilities too.
That's a really good point about the mirrors. So do you have any general recommendations for the kinds of mirrors that researchers might want to use in these systems?
Yeah, yep. So mirrors that are used for projection systems, they're what we call, or that what everyone calls, a first surface mirror. So if you look at a commercial mirror that you might have in your bathroom, you'll see your reflection in the morning. Great. But what you'll notice is that if you take any sort of implement like a pen, for example, and you go and you touch in the mirror, with that surface, you'll notice that the reflection of your pen in front of that mirror is actually going to be separated by the thickness of the glass that's interposed between the reflective surface and the pen. Okay, so you're actually going to see a gap between the pen and its reflection. Those are the mirrors you don't want to use in the projection systems, because they're what we call second surface mirror. The reflective surface is the second one after the light beam arrives. So those have issues with doubling images, maybe adding some blurring. Sometimes they're absorbing on certain wavelengths. What you want is the first surface mirror, the one that is much more fragile, but it's very planar, high quality, and that receives and reflects the light immediately from the moment that it contacts with that first surface. So they're typically available from specialized manufacturers, but we also offer the service to make sure which size you need, and also carry some mirrors for some certain circumstances. Yep.
Well, thank you so much for your time, Sophie. This was great. So if one of our viewers wants to learn more, wants to get in touch with you about their specific concerns for their installation, what's the best method to contact you?
Well, I think the easiest way is to contact us at scientist@vpixx.com. That's scientist, no S, VPixx, VPIXX.com.
I'll put a link in the description of the
I
video.
figured as much. Because this actually, it can reach me. And you can ask for me directly, but it also is going to be contacting our whole group of staff scientists. So we're happy really to discuss all of these concerns. But also, in more generally, we have a contact page on our website, which I imagine you'll be putting on too.
Yep.
And this also has contact information, contact emails for various departments at the company here. So you might decide to contact support. Somebody might decide to contact the support group if it's about an already existing installation that they want to adapt, or maybe through the scientist or sales email if it's something wholly new and they'd like to have a bit more of a scientist approach to it. But in all cases, if at any point during the consultation there requires a staff scientist, will be contacted and be alerted. We got people on all levels.
So I'll also mention that in 2023 at VSS, you gave an excellent talk on projection systems in a more general sense, right? Including MRI installations, including larger behavioral installations. We're going to have a recording of that talk available on the YouTube channel as well, and I'll make sure there's a link to that in the description below. So if anyone really wants to take a deep dive into installing systems, projection geometry, principles of projection, they can also take a look at that video.
That'll be great.
Yeah. All right. Thanks so much for your time, Sophie.
And thanks a lot for conducting this.
All right. Take care.
Bye-bye.